This video will demonstrate how to create a p-control chart in Excel. P-control charts are used for attribute data, specifically where we have a sample of a certain number of data points, and we want to see which of those data points meet a certain criteria. In this example, what we have is 19 samples of 20 M&Ms taken from an M&M production process. The attribute that we're interested in is whether or not the M&Ms are blue. This is a binomial experiment. Binomial meaning we can categorize the results into two categories. In this example, the categories are blue or other colors. So when we say sample successes, all we really mean is that those are the number of units that have the attribute that we're concerned with, which is that they're blue. The sample size in each sample is 20. To create a p-control chart, we need to calculate the sample proportion. We'll just simply denote that by p. The sample proportion is simply the number of blue M&Ms, or the sample successes, divided by the sample size. In this case, the sample size is entered in column C. Once we enter this formula in the first row, we can copy it to all the samples. Once we have all the sample proportions calculated, we want to calculate the average of the sample proportions. This is usually denoted by p bar. We simply use the average function in Excel and calculate the sample proportions. Next, we need to calculate the standard deviation of the sampling distribution. In this case, the formula for the standard deviation in the sampling distribution is based on p bar. The formula is the square root of p bar times 1 minus p bar divided by the sample size. It's important here to be sure we divide by the sample size and not the number of samples. In our example, the number of samples is 19, but the sample size within each sample is 20. Once we have the standard deviation calculated, we can place the other columns that we need on the chart in the spreadsheet. We have a column for the center, and the center of the control chart is simply p bar, or the average sample proportion. We enter this with an absolute reference. We copy this all the way down to all the rows to make it easier to create the control chart with the line chart function in Excel. The p-control chart is based on setting control limits for a certain number of standard deviations above and below the center line. This number of standard deviations is usually denoted by z. 2 or 3 are common values for z, but this needs to be set by the manager, who decides how wide the control limits should be. The width of the control limits will determine how many points we end up investigating to see if there's a special cause of something wrong with the process. If we believe that errors are only costly if they're widely out of the range of the center line, we might set a larger value for z, like 3. Now we need to calculate the lower control limit, LCL, and the upper control limit, UCL. the formula for the lower control limit is the center minus the value for z times the standard deviation of the sampling distribution. We reference the z value and the standard deviation with absolute references so that we can copy these down the spreadsheet. What we see when we first initially enter the formula is that the result is a negative number. We can't have negative numbers for control limits on P control charts, so we need to make an adjustment in the formula. If the result of this formula is negative, we simply want to set the value to 0. We can do this with the max function. We enter the max of 0, a comma, and then the control limit formula. So what happens is, if the control limit formula is negative, this function will set the value of the lower control limit to 0. If the control limit is positive, it will simply keep the value of the control limit formula. In this case, we already knew the result was negative, so we see that the function sets the value to 0. The upper control limit is the center plus the z value times the standard deviation of the sampling distribution. Each of these control limits we copy all the way down the sheet because this will facilitate creating a very simple, easy line chart in Excel. With these 4 columns created, we highlight the columns, the labels, and all the data. We go to Insert and Line Chart and select the second option tab. To make the control chart easier to view, we can right-click in the white space of the chart, select Move Chart, and put the chart in a new sheet. What we see here are that we have one point outside the upper control limits. This was a sample there where there was a very large number of blue M&Ms. And we may want to go back and investigate what happened at the point in time when this sample was collected to see if there's anything causing an unusually large number of blue M&Ms. What we're trying to see is that the proportion of this attribute of interest is consistent over time.